Just read this question. Have you seen these kinds of questions? This is 2.5. Okay, it's probably written differently, but it's 2.5. Can you identify these kinds of questions? You would have seen these if you're practicing. Yeah. Now I'll solve this using the conventional method, and then I'll tell you a new method. I'll just use the conventional method for this question. After this, I won't be touching the conventional method. Okay. So it says that walking at 3/4 of his normal speed, a man takes 2.5 hours more than the normal time. Find the normal time. Okay. Very simple question. So assume that V is the normal speed, right? V is the normal speed, and T is the normal time. Okay. What is the distance traveled? It is Vt. Right now, obviously, he's saying that if he travels at, he's reducing his speed, right? The speed becomes 3/4. So obviously, the time is increasing, right? So Vt, which was the original distance traveled, should be equal to Vt only, which is traveled in a different way when he travels at 3/4 of its speed. But what will be the equation? It will be the new speed, which is 3/4, into the new time, which is original time plus 2.5. So I'll write 2.5 as 5/2. Clear on this equation? Now let's just try to solve it. Okay, V anyway gets cancelled, so obviously a good thing is that we can directly find out T. Okay, I'll explain again. See, V was your normal speed, T was your normal time, right? So distance traveled was Vt. Now when he travels at 3/4 of his normal speed, he takes extra time, right? He takes 2.5 hours more than the normal time, but the distance traveled is the same, right? So if distance traveled is same, the left hand side is also distance, right hand side is also distance traveled at different speed and different time. So distance has to be equal. So if this is Vt, this should be equal to 3V/4 into T plus 5/2, right? Now VV gets cancelled. So if you just cross multiply this, you will get 4T/3 minus T is equal to 5/2, right? Right? Which means that T/3 is 5/2. T/3 is 5/2. Which basically means that T is nothing but 15/2. Right? You had to find a normal time. Normal time we assumed as T. So your answer is 7.5 hours. Anyone has any doubts in this basic method? Fine. Clear to everyone? This is the basic conventional method of how you're going to solve this. Now, let's look at a faster method, right? Just remember this because ultimately you will arrive at this, right? Just remember this. T/3 is equal to 5/2. Okay. I'll just rub this off. Yes, boat stream problems are also common in CAT, but for today we are not going to discuss that. Okay, I'll just remove this. I'll use the second method now, which I would recommend you should use, which is very, very fast. Right? I explained to you that V into T is constant. Right? If V into T is constant, and if somebody is changing the speed from V to 3V/4, what is the new time? From the concept that we discussed, the new time should be 4T/3, right? If T is the original time. Yes, races is the next thing that we are going to discuss, specifically linear races. Okay, this is something that we discussed already. If V changes to 3V/4, time should change to 4T/3, right? Now, if the time is changing to 4T/3, what is the extra time that he's taking? Earlier he was taking T. Now he's taking 4T/3. So the extra time is T/3. But what is the extra time given to you? He takes 2.5 hours more. So the extra time is 2.5, which means that T/3 is 2.5, right? Which is what we got using the previous method also, but we got it very quickly, right? So from here also, again, you can see that T is nothing but 7.5. Okay, clear? So let's see another question. Yeah, let's do this. This is an actual CAT question. Anyway, this is just an application class. This is not a problem solving class, so I don't expect you to solve this. Anyway, a man leaves his home and walks at a speed of 12 kilometers per hour, right? Reaching the railway station 10 minutes after the train has departed, right? If he instead had walked at 15 kilometers per hour, he would have reached the station 10 minutes before the train's departure. The distance from his home to the railway station is, right? Obviously, the distance from the home to the railway station is fixed. The only interchanging that is happening is between speed and time, right? So he changes his speed from 12 to 15. If he changes his speed from 12 to 15, what is the ratio in which he's changing? He goes from 12 to 15, right? So this is like, if this was V, this is 5V by 4, right? Right? The speed is changing by 25%. So if T was the original time, let's say T is the original time, right? If T was the original time, then what will be the new time? New time T dash will be nothing but 4T by 5. It is just going to be the reciprocal of this, right? Understood? If T was the original time and the new time is 4T by 5, what is the time being saved? The time being saved is T minus T by 5. Sorry, T minus 4T by 5, which is T by 5, right? This is the time saved. But what is the time saved given in the question? Earlier he was reaching 10 minutes after the train's departure. Now he's reaching 10 minutes before the train's departure, which means that he's saving a total of 20 minutes, which means that the original time that he was taking was 100 minutes, right? Are you clear on this? Okay. Anyway, so now the time is 100 minutes, right? The original time is 100 minutes, but what was the original speed? The original speed was 12. So what is the time? What is the distance? Distance is speed into time. So 12 kilometers, but this is 100 minutes, right? This is kilometers per hour. So you need to convert 100 minutes into hours. 100 minutes into hours is 100 by 60, right? Which is nothing but 5 by 3, right? So you get your answer as 20 kilometers. T by 5 will become 20 because you are saving T by 5, right? Earlier you were taking T, now you are taking 4T by 5 time, which means you're saving T by 5 minutes. But what is T by 5 in the question? Read the question. He's saying that when he was traveling at 12 kilometers per hour, he was reaching the railway station 10 minutes after the train had departed. Now he's reaching 10 minutes before the train's departure. So how much time is he saving? He's saving 20 minutes, right? If the train was scheduled to depart at 6 p.m., earlier he was reaching at 6:10, now he's reaching at 5:50. How much time is he saving? See, if number is weird, the concept does not change. Only the calculation will change. So theta is basically for those questions for which you don't have options, right? So this is type in the answer. So theta means this, type in the answer, right? So you have to type in the answer. For this, you don't have any negative marking, but you don't have options either. Okay, so this is a CAT question. I think this was asked in CAT 2017, if I'm not wrong. Now you can clearly see this. If you know this, this is like just figuring out 12 to 15 is a change of is like 5 by 4 times. If this is 5 by 4, time is 4 by 5. If original was 1, now time is 4 by 5. You have saved 1/5 of the time, and 1/5 of the time is like 20 minutes. You take 100 minutes, and then 100 minutes into 12 kilometers per hour is your answer.